Hey guys, so this unit for our chapter 12.7 is what is pressure, and this unit you guys are going to be able to identify pressure as a force acting on a unit of area. So how far is that force being spread out? Is it really concentrated in one point, or is it really broad? And you're going to be able to do this so you can calculate pressure. So if I give you a force and the area, you should be able to calculate how much pressure is there, and explain how to increase or decrease the pressure within a system. So what can I do to change the pressure? We're going to go and, for this unit, use these triangles of science. They're going to help us do some of this math involved. So the first thing we need to make sure that we understand is what is pressure. And pressure is a force acting over a per unit area. So how many newtons are you applying, and over what size are you applying that? And so the area can generally be like meters squared or centimeters squared. Typically, when you guys have heard of pressures in the past, it's usually referred to as PSI. And so that would be in the English system and not the International Science System or International Metric System for this. So you guys may have heard something called PSI, or pounds per square inch. In science, it's the same measurement that we would use. We still use the same units. We just label them differently. And so instead of pounds for our force, like weight, we use newtons, as you guys learned in the last lab. And so our force is going to be in newtons. And instead of square inches, of course in science we don't use inches, that's going to be in generally meters squared or centimeters squared. And so you've probably heard of PSI before, maybe not for pounds per square inch. So we're going to be using, for pressure, we're going to be using newtons per meter squared. We have these lovely triangles of science here. So if you're trying to solve for pressure, the P down here in the triangle, you can cover that up, and the formula becomes force divided by area. If you're giving a pressure and area and need to solve for force, you can cover up the force, and that's going to be pressure times area. And if you're giving a force and a pressure, you can figure out the area it's being applied to by covering up the A here, and that's tells us the equation is force divided by pressure. Let's go ahead and take a look at what one of these problems might look like. So, how much pressure is produced by a 30 Newton force acting on an area of 10 meters squared? And so, of course, looking at our word problem, we're going to see it's how much pressure is the key word. So we know that that's what we're solving for as our unknown. So we're going to cover up that P and see that our force and area are given. And so we're going to use the force divided by area, since the F is on top of the A. And so our answer for this one of 30 divided by 10 is going to be 3 newtons per meter squared. Make sure that you guys keep track of those units. And that is the calculations for pressure. For the remainder of the unit in this video, I'm going to read off the section in the textbook for those people that prefer to have it read to them. If not, you're welcome to read it to yourself. Okay, so the reading for this section is going to begin on page 260. Force and area. The amount of force acting on a unit area is called pressure. Pressure is equal to the force divided by the area. Suppose you hold a can as shown in figure 12-23. If the can weighs 10 newtons, it presses down on your hand with a force of 10 newtons. Now suppose the bottom of the can is an area of 100 centimeters squared. The pressure caused by the weight of the can on your hand can be found by using the equation. Pressure is equal to the force divided by the area. So pressure is equal to 10 newtons divided by 100 centimeters squared. After the calculation, you'll get an answer of pressure is equal to 0.1 newtons per centimeter squared. Changing pressure. Pressure can be changed by changing the force. When the area stays the same but you increase the amount of force, you increase the pressure. Think of a pencil point. Press the point gently against the piece of modeling clay. The point of the pencil will make a small dent in the clay. If you press a little harder, you can increase the force and the pressure.
the pencil point will sink deeper into the clay. Pressure can also be changed by changing the area in which the force is pushing. If you apply the same amount of force to a large area, the pressure is decreased. Think of the same pencil. Turn it around and gently press the eraser against the clay. With the same force you used before, the pencil barely make a mark in the clay. If you increase the force, the eraser will dent the clay, but will not sink in the clay as far as the pencil point did. This shows that pressure applied with the eraser is less than the pressure applied with the point of the pencil. Pressure in nature. Pressure can also be found and felt in nature. When pumped into a tire or a balloon, air exerts pressure to keep items inflated. Air pressure in a tire can be great enough to support the weight of a truck. The pressure exerted by moving air or wind can turn vanes in windmills and keep a kite flying. Deep below the Earth's surface, pressure is very great. The weight of the rocks and the soil above can cause dramatic changes in the rock at great depths. Pressure builds up to cause volcanoes to erupt and earthquakes to occur. At this point, you guys can look at the checking concepts, thinking critically, and working on your building and math skills. Thank you. Have a good day.